Good afternoon to my subscribers, especially for class 9 students. Very good afternoon to you. Hope all of you doing well, attending your school regularly and learning the subject um, very curiously, and you are listening the classes very attentively. Let's Thank you for watching my videos, class 9 students. I am kindly requesting to you, please focus on your studies by watching my videos, by listening in your school by your subject teacher, and read your textbook as usually, right? It is very useful to you. And like the video after watching. If you like it, make a comment. The most important thing is the comment. So do comment and share the channel, share the video to someone, and ask them to subscribe. Still, if you are not subscribed, please subscribe, like, comment, share, and subscribe. This is my request to you all, not only for class 9 students, for class 10, for class 8, all are requesting. Please like, share, comment, and subscribe. Okay. Then in the previous video, we discussed velocity and some numerical, simple numericals only, and we discussed the speed and velocity, speed and velocity, right? Then next topic, describing motion by acceleration. Today our topic is acceleration. So generally, this term acceleration are able to hear in many cases, in some situations. So accelerated. So press the accelerator to accelerate the vehicle, right? Accelerate your life. This is the time for accelerating your life. So this is the time for accelerating your studies. Then before then examination time, if it has 2 or 3 months, then the parents, friends, relatives, teachers, all are advised accelerate your studies. Then pick up speed. You must be increase the speed, must be focus more and more. Then while watching cricket, the commentator use this word, accelerating the innings. So whatever it is, what is meant by this, what is meant by acceleration? What is meant by acceleration? Acceleration means, before that is the body moves continuously with the same velocity. No, it is not possible. It is not possible. We are able to change the velocity. We are able to change the velocity by changing the direction, by changing the speed. By changing the direction, we are able to change the velocity. When the body of velocity, when the velocity of a body increasing, the body is said to be accelerating. Suppose a car starts off from from rest, and its initial velocity increases a steady rate, so that after 5 seconds its velocity is 10 meter per second. That means a car or a body starts at t is equal to 0 seconds. At t is equal to 0 seconds, at time t is equal to 1, its velocity is equal to 2 meter per second. 2 meter per second. Then it is called as initial velocity. It is called initial velocity. After time, after some time, for example, at 10 seconds, at 10 seconds, its speed is 5 meter per second. 5 meter per second. This is final velocity. This is final velocity. So at 1 second, at the 0 seconds, at 1 second, its velocity is called initial velocity. Initial velocity is 2 meter per second. After 9 seconds or after some seconds, so its velocity is 5 meter per second. Is the velocity increases or decreases here? Velocity increases or decreases? Absolutely increases. Absolutely increased. How much time it's increased? How much time it increased? Uh, right, we can, or if you take 6 and if you take 6, how much time it increased? 3 meter per second. 3 meter per second increased. 3 meter per second increased. That means 3 meter per second increased speed. In other words, the rate at which the velocity increases, the rate at which the velocity increases from 2 to 6 meter per second, 2 meter per second to 6 meter per second, 6 meter per second. That means for every second, for every second, for every second, its speed increases 3 meter per second, 3 meter per second. 2 meters per second, 3 meters per second in every second. The car is said to have acceleration of 2 meters per second per second. Per second means initial velocity is 2 meters per second, final velocity is 6 meters per second. That means if the time is t2, time is 2 to 10 seconds, t to 10 seconds or whatever the time it is, its change in velocity is 3 meter per second. That means a car travels or its speed or velocity is 3 meters by second for every second. For every second. So we can say to be it is accelerated. Mean for every second the speed of the car increases or the velocity of the car increases 3 meter by second. 3 meter by second. That means initial speed at starting it has one speed. After some time it has some speed or velocity. After some time it has some velocity. So when the time is changes, there is a change in the velocity of the car. First it is 0, then it is for 2 meter per second, then it is for 4 meter per second, then it is for 6 meter per second. That means for every second the velocity or the speed, the velocity or the speed of a car increases. Increases how much? 2 meter per second. 2 meter per second. So that change in the velocity or the speed, the change in the velocity or the speed is called acceleration. So the rate of change, the rate of change of velocity, of velocity, velocity of the body is called acceleration, is called acceleration. So acceleration equal to acceleration, acceleration equal to change in velocity, change in velocity, change in velocity by time, change in velocity by time. So we can represent with a is equal to v by t, a is equal to v by t. A is equal to V by T. Sometimes you can write delta V by T. Delta V by T. So here change in time means velocity means final final velocity minus initial velocity. Final velocity minus initial velocity by time. So we can represent the final velocity with V. We can represent the initial velocity U by T. So A is equal to V minus U by T. Change in velocity. Change in velocity. The delta represent to change. So final velocity minus initial velocity by time. Final velocity minus initial velocity by time, that is called as the acceleration. It is called as acceleration. Then SI unit. Then SI unit is equal to, we know velocity units, meter by second and divided by t and divided by second, that equal to meter by second square. So the SI unit, the SI unit of acceleration is equal to meter by second square. In CGS unit, centimeter by second square. Centimeter by second square. So this is called acceleration. The rate of change of velocity with the time. The rate of change of velocity of the body with the time. With the time. With the time is called acceleration. Is called acceleration. It is a vector quantity. Acceleration is vector quantity because velocity is a vector quantity. Velocity is vector quantity. Vector quantity. It acts in a particular direction. Particular direction. So, for example, if the body is moving with a uniform velocity, the body is moving with a uniform velocity, then A minus V by T equal to 0. No change in velocity, no change in velocity, no change in velocity. So the acceleration will be equal to 0, will be equal to 0, right? Then uniform acceleration. Uniform acceleration. A body has uniform acceleration if it travels in a straight line. If it travels in a straight line and its velocity increases by equal amount. If the increasing velocity, if the increasing velocity is equal in equal intervals of time, in equal intervals of time, we can say to be uniform acceleration. Uniform acceleration. Uniform acceleration means velocity increases equally. Velocity increases equally in equal intervals of time. In equal intervals of time. In equal intervals of time, then we can say to be uniform acceleration. Uniform acceleration. A body has uniform acceleration if velocity changes at a uniform rate. At a uniform rate. For example, at t is equal to 1, 2 kilometer. T is equal to 0, 0 as usual. And t is equal to 1, 2 kilometer or 2 meters per second. T is equal to 2, 4 meter per second. Then at t is equal to 3, 6 meter per second. Time interval 1, 1, 1. Speed, change in velocity 2 to 4, 2, 2 to 4 to 6, 2. Time gap 1, time gap 1. For every second, for every second, the velocity changes 2 meter per second. up to every 1 second, the change in velocity is 2 meter per second, 2 meter per second, 2 meter per second. Such is called as a uniform acceleration. Uniform acceleration. Uniform acceleration. Right? Then the motion of freely falling body. The motion of freely falling body is an example of uniform accelerated motion. Uniform accelerated motion. The motion of bicycle going down, the motion of bicycle going down the slope of road, the slope of road when the rider is not pedaling and wind resistance is negligible is also example of uniform accelerated motion. Moving on a slope. While riding bicycle, if it is a slope, if the person not pedaling and if he neglects the wind force or the air force, then the body is in the uniform accelerated motion. The motion of a ball rolling down an inclined plane, even the slope, if a ball is rolling down, if a ball is rolling down, in this case also, it is means the change in the velocity for every second is same. The change in the velocity for every second is same. That's why increasing velocity same in equal intervals of time. This the ball or the freely falling body, the cycle moving on the slope road is example for uniform accelerated motion. Uniform accelerated motion. Then non-uniform accelerated motion. Non-uniform accelerated motion. So change in velocity is different. Change in velocity or increasing velocity is unequal amounts in equal intervals of time. Unequal amounts in equal intervals of time we can set to be non-uniform acceleration. Non-uniform acceleration. Right? So the speed or velocity of a car running in a crowded road or in a traffic is example for non-uniform accelerated motion. So non-uniform acceleration means the car has non-uniform acceleration. This change in velocity means the rate of increasing velocity is called acceleration. Is the velocity of the moving body always increases, or sometime it will be decreases, So later we discuss.